Okay, so the big thing that we're going to talk about this chapter, which is chapter 3, this is the first video in chapter 3. And we're going to talk about two-dimensional motion, but we're also going to talk about vectors. Vectors are really, really important, and people get hung up on this vocabulary, but it's not all that hard. A vector is a quantity with a direction. So the key thing is with a direction. Now, in the book, you're going to hear a lot of places. You're going to hear magnitude and direction. And it's kind of hard for me to explain what magnitude is. Magnitude is just a size, it's an amount, it's a quantity. So I would say magnitude is a quantity. Okay, so when we're talking about something like displacement, with displacement, we're going to say something along the lines of how far away from a point are you, and in what direction. And then we're also going to say velocity. How fast are you going? And in what direction? So you get the point. One more. Acceleration. How fast is your speed changing? Finish it for me. And in what direction? Okay, so we had, in the previous thing, we talked about how the acceleration of gravity gravity was always negative 9.81 meters per second squared. Okay? And so that negative meant that the acceleration due to gravity was always down. Down was the direction. So if I've got a car, here's my car. I have a couple of questions. So if I'm going to go, if I'm accelerating this way, that means that basically if I'm thinking about a car, I am speeding up generally. If my acceleration is going this way, I am generally slowing down. We'll forget that, okay, so my car doesn't have a reverse gear in it. So my car only goes forward, it doesn't have a reverse gear. So if I'm accelerating, it basically means in the forward direction, if I'm accelerating in the forward direction, I'm speeding up. If I'm accelerating in the backwards direction, it means that I'm slowing down. If I am accelerating to the side, that is going to mean that I am turning. We'll figure that out in a later chapter. Or it could mean that I'm in an accident, that somebody's T-boning me from the side of my car, and so that's causing me to accelerate sideways. But let's hope that I'm turning and not in a accident. Okay, so in all of these I could have the same number. I could say that this is 1 meter per second squared, 1 meter per second squared, 1 meter per second squared. And they would all have the same quantity. All the same, I'm going to use the word magnitude. But different directions. So, vectors. Vectors. Quantity plus direction. And direction is really, really important. Okay. Now, so we gave some examples of vectors already. I'm going to list them out again. Vectors. We'll say displacement, velocity, acceleration, and we're going to get into some other ones later. Momentum, force, electric field, magnetic field. I could go on with some others, but that's going to give you some idea that there's some things that are going to be a little bit different, that are not going to really be, they're not going to be measured in meters and seconds. Displacement, velocity, and acceleration are going to be in meters per second, but momentum, force, electric field, and magnetic field in particular are going to add in other concepts. Now, what do we call an object, or let's see, a pure quantity without direction? What are some examples of that? Well, let's say mass, kilograms. You don't have a mass of 68 kilograms in any direction. Temperature. It doesn't make sense to be 40 degrees C up. It doesn't make sense to be 40 degrees C up. It has no direction. So quantities without direction are scalars. And we're going to end this right there.